Okay, so hello everybody. I hope you can hear me well and that you can see my screen that I've just shared. So it's a pleasure to welcome you to this masterclass connected to Master DSBA, which means Data Sciences and Business Analytics. So I remind you, this is a joint master between two schools, Business School, which is where I am a professor, and Central City Engineering School. And the master is joined between the two schools with two campuses in front within the two schools. So you'll have more details, or maybe you had more details about this program. But the purpose of today's talk, my talk, this masterclass, is to present you a case study, an example of analytics that actually I teach in my course. And then that this talk is one of the courses of the master that is called Decision Analytics. Actually, this is taught in Master 2, because as you know, there are two years, Master 1 and Master 2. Okay, so my name is Laurent Alfandari. I'm a professor at the ESSEC Business School. So I'm one of the co-academic directors. We have two professors for ESSEC and two professors for Central City. And I am at ESSEC Business School in the Department of Information Systems, Decision, and Statistics. Okay, so my talk today will be about decision analytics. So it's part of analytics. I will explain the difference between the other parts of analytics right now. Okay, my case that I'm intent. So I'm not going to do you theory. I'm going to speak over a case study, like from a kind of company that wants to design a network and actually a logistics or supply chain networks. So we need for these models, decision models, because what I'm going to present you today is decision making. And decision making where decisions to make are not that simple, not intuitive, but you need tools, you need models to help you, because it's not just like this. You have to support your decision making by some analytics and models. Okay, so let's start. What I'm going to present today is a field of research and science that is called operations research. So I don't know if you heard this word. If you did if you have some engineering background, I'm pretty sure you heard of operations research. If you did some management background of economics, it's more rare, but this is connected to optimization and decision models. Okay, so Pierre Bateau who's a researcher, defined operations research as, I have to put my, to a set of models aiming to solve some problems of organization. So it seems that maybe you don't see well because I have many things. I hope you can see well. Some problems of organization, planning, and resource allocation. So it's a toolbox that contains decision models, optimization, whatever the kind of optimization. I'm putting some different kinds of optimization here. Linear programming, that we teach, graph theory, MDP, which is Markov decision processes. What I'm going to present today is part of, I have maybe to put that there. Maybe that would be easier for you to see if I share my screen. So this is part of prescriptive analytics. So let me explain briefly. In this master, we do analytics, data analytics, business analytics, data science. There are three parts in analytics. Basically, three stages, 1, 2, 3. The first is analytics. So that's basic statistics. You analyze the situation. You analyze the present and the past. Why do you do that? You do that for the second stage, which is making forecasts, okay? Making predictions. And that's called predictive analytics. That's the second stage. So you use data, you use information to make predictions because you want to see how it will evolve. For example, the market, the demand, the result of a legal action, for example. You want to see what will be the forecasts. So what will be the future? An estimation of it, of course, and you make errors. And then this is where you use machine learning, deep learning, all these kind of techniques and AI to make predictions. And more usual statistics and forecasting methods. And then why do you make predictions? Well, it's not just for getting information. It's not for your just culture or knowledge. Knowledge is here for decision making. So that's the final stage, is deciding. And that's where I'm going to present things to you now. So deciding is prescriptive analysis. Make a prescription like a doctor. You know, the doctor makes a prescription. So we want to make decisions that are suitable, that are good, that satisfy maybe some constraints, and that actually, for us, we'll say they are optimal, which means they match a given criterion of performance. What managers often say, KPI, key performance indicator. We have several KPIs, but we optimize one at a time. Okay, so, okay, maybe this bar is a bit, yeah, maybe put it here or there. That will be better. Okay, so I will focus on prescriptive analytics, but you have to know that in the master, we have lots of the courses are more predictive analytics, meaning statistics and making forecasts. So the stages 1 and 2, but also at the end, and because there is a management school like ESSEC, in part of this master is to make decisions, okay, and hopefully good decisions. So this is a master class. At some point, I will stop to ask if you have questions, and it'd be a pleasure to answer. So let me just present a bit the thing. Okay, so now trying to go to, okay, and we'll speak of models today. So what a model is. The key word to define a model is a representation, which means model is not reality, as you know. It's a representation. And this representation is in some formalism, which means a formal representation. What does it mean formal? It means that it's described in some specific language. This is not English, could be English, okay, natural language. But very often it could be graphical language, as you see here. And sometimes it's mathematical. And math is a language, okay? So why? Because very often you describe a class of phenomena, like let's say some kind of reality. And you want to transfer this reality in some language. And as you see, my examples here, they're very, very often graphical, which means this is not a house, but a kid could guess that with this square, this rectangle and this triangle, this is a symbol of a house. Of course, the real house is much more complex than this. But this represents a house with just a few elements. These are the indifference curve in economics. What does it say here? Pasta and rice. It says that, you know, in economics, this indifference curve means that you have some exchanges of goods between, for example, two products, rice and pasta, such that X1 kilograms of rice and X2 kilograms of pasta have the same satisfaction as another combination X1, X2, which means between 3 and 2 kilograms of the two products, or maybe 4 and 1, the customer has the same level of satisfaction, okay? Or utility, let's say. And then you're on the same curve. And what is it interesting? Because you can exchange goods. It's a good formalism to explain that you can exchange goods. Okay, so when you're the same, where it means you are indifferent between the two combinations of products, and if you're indifferent, you're okay to exchange. And then you have a market. Then you have the third drawing here, maybe you know it. It's in sociology, it's called the Maslow pyramid. What does it say? It says, Maslow said that there is a hierarchy of needs, a hierarchy, a priority. You have the most priority needs to the least priority needs. And at the time of Maslow, food and security were the top priority, and leisure at that time was not so shared by all people. It's more the case now. But this pyramid still has a sense when you saw what happened with the COVID situation and the lockdowns. What was first allowed as shops was food. Okay, so in France, for example, they forbidden to sell books in the supermarkets. Okay, but they restricted foods. You could still go first necessity goods, you could still buy them. Okay, what I want to say here is not, is it correct or not? What I want to say is that the formalism that is chosen is a drawing, is a graph, okay? So it's something visual, so that people, students, can understand the basics of the phenomenon you want to describe. You have an electrical circuit here. And then the last one, with this maximization problem, it's like what we call a linear program, an optimization problem. X1, X2 are variables, could be the number of tons of product one produced and product two. And this is actually an optimization problem. The second one here is a graph. And the difference between the last one on the right and the four ones on the left is that the four ones are models that are called descriptive. They want to describe a reality or try to explain or to describe. Descriptive models. But the last ones, and the one I will present you today, is not just to describe the situation. It is to decide. Actually, it's to help to decide. Okay? It's a support for decision making. So it's not just describing a situation. It's not just for knowledge. It's using the knowledge to make good decisions. Okay. So a bit of history. I like the story of where does it come from. Okay, I see the chat something. Okay. Yes, if you want to ask questions during the chat, you can. That will be maybe easier. And from time to time, I will check the chat. Okay, so I hope then I have to put that off because even that. Okay, so that you see well. Okay, so the operations research was born actually during World War II. I'll try to put that, I guess, maybe that's better. World War II, during the Second World War, because operations comes from military operations initially. Then it came to manufacturing industry, and then it came to management in general, in science. And during World War II, there were many problems of optimization because the armies wanted to construct material in a short amount of time, because you have to have your ship ready for the battle. So there was a big stake to be ready on time. So this is where all the project scheduling, project planning methods, like PERT method, were born, to construct rockets, to construct planes, to construct anything, ships, and so on. To construct military construction project in a minimum amount of time. Now you do that for a house, building a house, you do that for launching a new product. In marketing, you do that for many other fields. But initially, this was born in the 40s. Another example that I show you is the radar location. Radar location is the UK was attacked by the German rockets, V1, V2, on the eastern coast, close to London. And you had identified a set of possible locations for radar to detect the rockets before they do damages to the population. And the problem was, out of these possible locations that are the small circles in gray, in green here, which subsets of location I will select to actually build a radar with the constraint. Okay, could somebody maybe guess what the constraint would be in this problem and what the objective could be? Maybe I can ask you through the chat. I managed to see the chat because now I have to see where it is. Here maybe. Okay, let me check. The budget. Okay, budget will be actually the objective function. So we will minimize cost. And if all radars have the same cost, it would be minimize the number of radars. So that will be the objective function. Okay. And if there is a different cost because you have to destroy houses maybe to build the radar and so on, so it's not the same cost depending on the location, then it would be a weighted sum and it's a budget. I agree. Now, what is a constraint? When you locate radars, what do you want to do? Okay, maximum number of people to say, says Xian. Yes, but that would be still an objective function, because if you maximize, I'm speaking more of a constraint. What do you want to be done, to be feasible? Think of, or what do you want to avoid? I'll just let you maybe a few seconds more if you have an idea. Otherwise, I will tell you the answer. Limited time could be limited time. Okay, the answer is that you want your covering to be with no hole, which means you see one of the key data is the radius of the radar, which is this yellow circle, the radius. So how many meters, 200 meters, 400 meters, that it cover? Then you want that your selected black points out of the green points, you want that this subset makes a covering that has no hole, which means it is continuous, there is no hole. So which means that the union of the yellow circles, depending on the radius, this union covers the whole coast with not a single kilometer that is not covered by the detection, which is not detected, because otherwise the rocket could enter without being detected. So that's, and this is not easy to model actually. But this is a famous problem that is called a set covering problem. It's very close to in marketing to locating, for example, commercial centers, shopping malls. Where do you put them? Okay, your Carrefour or Auchan or whatever the brand, Walmart. Maximal coverage of the demand. Okay, so this is kind of a application. Now you see here today's application. So I will solve. Okay. Second constraint it's for every customer. Each time you have a demand satisfaction. So I say for every customer I, between the 21 customers here, the sum of the percentage, all the demand is served, which means the sum will be 1, meaning, as I said, 40% will come from here, 30% from here, 30% from here. But it 80%. I don't want to lose any demand. So all the demand is served. This is this constraint here. M is the number of sites, 8, okay? M is 8. And the last constraint that you see here is the capacity of the plant. It is to say, the left-hand side of the constraint is what the facility J will actually supply to all customers. Well, it will supply, it decomposes, that's why you have a sigma. It decomposes by customer of the number of tons it served to this customer. And what is the number of tons it served to this customer I? Well, it is this demand of I, di, multiplied by the percentage of the demand that you decide to serve him or her. So di multiplied by xij. Di in ton, xij is a percentage, so you have tons. You have tons on the left and you have tons on the right, because we say, actually it's a mistake here, it's 11,000 tons. I say my data. This is the capacity of each plot. So I say, anyway, the total demand is something like 31 kilo something. On the right-hand side, it's 11,000 multiplied by yj, which is a binary variable. So if yj is 0, which means you don't open the facility, the capacity will be 0. So nothing will come out from this site. That remains an empty field. But if yj is 1, then the capacity will be 11,000. And this is the true capacity of the plant. Okay. And last but not least, here you have the objective function. So the objective function you have to pay attention, but this is the average number of kilometers to supply 1 ton per ton. Okay. So which means the total number of kilometers to serve all tons. So here, this double sum to serve all the tons to all the customers In supply chain, they call that ton kilometers, ton multiplied by kilometers. And you divide by the total tonnage, the total demand in tons. So you divide ton by kilometers divided by ton, you will have an average number of kilometers per ton. So in average, how close are you to your customers? And you have to weight by the demand because, as I said, you have large customers and small customers. Okay. I just make a very short break in case there is a question about this before I go to solution. No, you will use Python and C++ in the master, but in the course you don't use Python. Why? Because we have modelers that directly translate this model into a language that is read by the optimization solver. So sometimes you can build by Python the model itself, but I'm answering the question on the chat, okay? But you don't need to. You can directly write this model with some syntax and give it to the solver. And it will give you the output file with the optimal solution. Now let's see the solution now. Solution is here. Okay, Excel file. So I have shared my screen. Okay, so now, how do I? Okay, I share another screen, which is this one. I'm checking time meanwhile. I hope I'll be on time. I think I will. Okay, so I'm using what is called Excel solver. Again, Excel solver is just for pedagogical reason. In the course, which is in Master 2, you will use like Cplex or Gurobi, other more powerful tools that can handle thousands of variables, which sometimes is needed. The crew pairing problems in airline companies, so assigning crews to the flights, it's millions of variables. That's one of the most complicated problems I know. Okay, so here is you have the data. Then look at the solution. So I skip the details, but I use Excel solver. Where is it? It's okay. Anyway, I won't show it to you because I want to be fast enough. But here you have the Excel solver. So let me show you. So here in blue, I put my decision variables. The Excel solver, you will see how to build an Excel solver and the models. But trust me, in Excel solver, you put exactly the constraint as the one with the sigma I wrote just before. So the optimal solution is to open 3 facilities at Montpellier, France, Lens, France again, and Prague. Okay? If you want no more than one site in France, you would say the sum of the French variables, Montpellier, so this plus this plus this, is less than 1. Then you'll never have 2 in the same country. You can add this if you wish. Now look at the solution. In blue, this is in tons. This is a model in tons. So this is the number of tons supplied to Montpellier from Lisbon. So you can see Montpellier will be completely supplied from Lisbon will be supplied from Montpellier, which is the closest. The same for Madrid. Montpellier is in the south of France, is the closest from Lisbon and Madrid. But from Le Havre, which is a customer, Le Havre is on the west of Paris, it will be supplied by Lens, which is in the north of France. And Frankfurt, which is here, will be supplied by Prague, which is in the Eastern Europe, which makes sense, okay? But look at something, this is a multi-source. Sometimes you have customers, where is Napoli? No, this is a multi-source. Okay, single source. I think I made a mistake. This is a single source solution. I will show you the multi-source solution. So what you see here, everything is delivered. The sum is equal to the demand. You have 3, the sum of the y variables is equal to 3. Sum of the yj is 3. The total production or supply by a factory is less than its capacity, which is 11,000. But you can see that Lens here is not at full capacity. So there is a reserve of capacity here, whereas these 2 ones are full. You could relax this constraint if you wish. That's easy to do. Okay. And then Yeah, let me see. And then the optimal solution is here. In average, you transport 1 ton over 524 kilometers, which if you use a truck that has average speed of 75 kilometers per hour, this means in average 7 hours to reach the customer. For example, for Amazon, that would be too much. Amazon has built its success on a very dense logistic network to be able to serve every customer in 1 day, but even less than 1 day, in half a day, and sometimes in 2 hours maximum. And you have contracts if you want to be delivered in 2 hours, half a day, 1 day. Okay? So that's why you see so many Amazon warehouses everywhere. Okay. But they use analytics. You know, actually, Amazon recruited 7 of our DSBA graduates this year. So lots of things, even for supply chain. But that's just an example. You do for many sectors: health, marketing, science, engineering, and so on. Let me see if this is the, okay, this is a single source. This is the same where variables are 1 or 0, which will be your supplier, okay? So exactly the same solution, but for single source. So now let me show you the PowerPoints of a team of students, actually the executive MBA, who did something just to show you. Yeah, diaporama. Okay, who did something about, okay, let's skip the introduction. So they did something very well, showing the results of visualization of the solutions. So you see, Lens is here, Montpellier is here, and I think it's Praha, which is here. And you see who serves what. And you see that in the multi-source solution, there are 2 cities. Oh, I stopped. Okay. I just had a message saying that my connection was unstable. So I hope you didn't miss too much of my last words. Can you hear me? Yes?
Yes.
Yes, okay. Thank you. Okay, so you see what the students did. So like they did not only the locations that you can visualize on the map, but also what are the flows, what are the assignments, what are the supplies between the customers. And then you measure the supply by the average distance, okay, or average time, whatever. And you see that Frankfurt and Napoli are the only 2 customers that have multi-source supplying, which means Frankfurt serves part of its demand from Lens, part of its demand from Praha, that are the 2 closest, and Napoli, part of its demand from Montpellier, and part of its demand from Praha. Of course, Napoli is a bit far away from everywhere. So I guess the quality of service for Napoli will not be that good. Whereas from Le Havre, which is close to Lens, or London, it will be much better. So of course, you have a dispersion, you have the variance. But in the objective function, I put the average. If you want to control the variance, you can. You can put a threshold on the maximum time you want to supply. You can put a norm 1, minimize the absolute values, the gaps to the average, okay? If you want to do the quadratic, the variance, it's quadratic, it's a more complex optimization problem, but you can still do. Okay, so that was nice what they did. They put the KPIs, the key performance indicators here on the right. They put the minimum average distance. They did the same for single source. So this is single source, a single assignment, 100% comes from the same place. It's very close to it. Why? Because the other solution was almost single source. So now it's single source. Now Napoli is only served by Montpellier. And Frankfurt is only served by Praha. And you switch to 535 24, a bit more, because you change a bit locally the solution. You see? Now, what I ask the students is, what if you change some data? For example, what if you could have budget for more sites than 3? So you see here, the more sites you have, if you have budget to construct more Kindred care centers, it's better because you can be closer to the customer. You can scatter more your locations. So, but at some point, it's not useful anymore. So you just gain marginally just a bit. But between 4 and 5, between 3 and 4, there is a big gap. Between 4 and 5, and after that, less and less. So you see, it's a bit convex like this. But is it worth? Well, it depends on your investment budget, because not only and the functioning cost, not only your quality of service. So this is always a trade-off. Management is a conflicting criteria. Economics. So of course the solution changes. Let me show you. They said, what if I I'm back. I hope you can hear me. Can you hear me? Yes, okay. Sorry for the interruption. My connection was unstable. Fine, so let me go back here where I was. Okay, so you can make a lot of sensitivity analysis, and this is called the exploratory power of the tool, which means you can build scenarios very quickly and get the new solution. Okay, so let's wrap up a bit. Limitation. Okay, I always ask for limitations of the case. What are the limitations of the model? Let's keep that. But that's very interesting to understand what are the limitations of the model, because a model is a choice to make. There is no science that would tell you what should be your model when you make decisions. Okay, I'm speaking of decision making. You have to make choices. You have to get rid of some aspects. You have to give priority to some other aspects. It's craftsmanship, artisanat in French. Okay, it's a mix of science, rocket science, is in the algorithms to solve the problem. Okay, so let me switch back to my slides. Conclusion. I will conclude now. Okay, so I don't know if you can see me. Yes, it seems to be okay. Oh, so this is a conclusion. Okay, so with these prescriptive analytics tools, you can optimize what we call key performance indicators: quality of service, delivery time, cost, market share, CO2 emissions, whatever. Very often it's cost minimization and cost cutting. But you can use this tool for sustainable development. I have a lot of cases with sustainability issues when you want to minimize emissions. So you have to decide. Nobody is there to tell you what should be your criterion. You decide your criterion. Okay? This is part of your strategy. If you're a low-cost company, you will choose a cost. If you're more in a luxury brand, you will favor the quality of service. Of course, under budget, but maybe this is less an issue. Okay? So you put the science in the solving. You still have quantitative model with math to model the problem, but you have to make choices about your model. Then you need to have, before that, the quality of the output of your decision model will depend on the quality of your input data. And very often, input data are not just fixed concept, but they are forecasts. So of course, you should have good predictive analytics. That's why in the master, we have a lot of these predictive analytics courses: forecasting, machine learning, deep learning, AI, and so on. Okay? So the quality of a decision model is dependent on the quality of the data. Make good predictions. Okay, you have to model first. Don't plunge into the solving. Don't try to solve the problem before you modeled it correctly. What are your criteria? Do I put this criterion as a constraint? Do I put this criterion as an objective? Are there several objectives? Okay. Time to market is, of course, in supply chain, I told you, for Amazon or this big company, these platforms, time to market is a key issue. So very often you would minimize time under budget, but it could be something else. Again, my fifth point is about the precision. Is it very important to double the volume of your model, to have many more decision variables and constraints, if your data are very imprecise? If you have 20–30% mistake on your data, you should not refine too much your model. You should adapt the precision of your model to the quality of your data. Okay, so then the point of the level of detail, operational versus strategic, I already spoke of this before. And just that you know that, of course, you deal with uncertainty with forecasting models and machine learning and so on. But also in optimization, when you do decision making, you have what we call stochastic optimization and robust optimization, where you can say that some parameters vary in some range, okay, with some control variation in some range, and you want to optimize your decision under the worst scenario, the worst deviation of your uncertain parameters. This can be done in optimization. This is called robust optimization. And we have tools to do that, okay? So that's more at the research level, but there are things to do that. Okay, so we are 5 minutes before schedule, and I think I'm done with my presentation of this case study I wanted to show you. Just as an example, what we can do with prescriptive analytics, that's quite representative of, okay, there are hundreds of problems in decision analytics, and some are not linear. Here it was linear programming, but if you minimize the risk of a portfolio in finance, it would be quadratic. If you are in the energy sector, there are a lot of nonlinear functions. This is more complex. You could have binary variables, 0, 1. That's more complex as well, because the solver is longer to solve. This is another issue. We can explain that. But you also have good predictive models to get the good data for your predictions and forecasts. Okay, I hope I was pretty clear. I'm sorry for the interruption, but if there are questions, I would be ready and pleased to. Okay, I see some questions. So I think Guillaume Chevillon will, after me, speak more of the master. So if there are some questions about the master, I guess my colleague, Guillaume, who is the other professor from ESSEC, will answer, but I can still have answers. So do you have to come from STEM? What do you mean by STEM? I'm sorry, but what do you mean by Ashantim? I cannot answer the question about the STEM undergraduate background to apply for this master's course. What I can tell you, because I don't.
Hi everyone. I think I'm going to take over from Laurent's presentation. In particular, if there are any questions regarding the master, I guess that's kind of the point today. So let me go through. Okay, sorry. Go through the quick presentation. So we have about 15 minutes for that. So don't hesitate to raise question in the chat if you want as well, or we can see that afterwards. So what I'd like to present you today is this master in data science and business analytics that we've had with Central Supélec since 2014. So it's going to be 10 years soon. And essentially, I mean, I guess you have access to the brochure, which is on the website. So we have, I recommend the ESSEC website rather than the Central Supélec website, because the Central Supélec website hasn't been updated recently. They're kind of a process of revamping it entirely. So all the relevant information is more likely to be found on the ESSEC website rather than the other one. But the brochure is up to date there. And then I'm here to give you a short overview. So one thing which is important, it's a dual degree. It's a joint degree between a business school and a school of engineering. And this being in France, we have French roots and are both global schools. So we have campuses around the world and students coming from everywhere. But the idea is that there's a part of the French education which is kind of embedded in this program, in the sense that we are very scientific in all approaches, and we try to really understand everything we do before we actually do it, which is a bit more like theoretically driven, that some types of education were more pragmatic, and when you actually first learn to do, and then you see what it is about. Here we're always a bit theory driven, which means that there's a strong focus on understanding what you're doing, because we believe that kind of the key creation of value for your the long-term prospects of your careers, is that if you're interested in learning about data science and the application to business, it's essential that you understand what you do, because it's very easy to produce an output, but it may actually make no sense and may actually jeopardize the company that you're going to be working with if you don't control what you're doing and the actual uncertainty surrounding it and the actual output that you're producing. So it's very important. That's why this is really a program that is very centered of understanding the basics. So it means that we actually go progressively, and we also one of the key features here is that we try to embed everybody depending on your background. I mean, and we have students from many different backgrounds. They're actually going to transform into a data scientist if they want, or somebody who was more like a data analyst, depending on what their career interests are. But there's really kind of this transformative experience, and that's kind of what we're trying to do. So no matter what your background, if you have a keen interest and you show some abilities and disposition, so if you kind of really prepared yourself so that you are convinced it is for you, so you've really had some on the side experience with data that you may actually have studied by yourselves or doing some online MOOCs courses, so that this is for you, and then you've convinced yourself this is for you, which is the best way to convince us this is for you as well. In that case, don't hesitate to apply. And the last thing we want to say is this is a master which is really focused on the interaction with the faculty and the courses. So we have very strong faculties at Centrale Supélec and at ESSEC, and we've been hiring a lot of very good new professors in the last few years, and they're all been very involved in the program. And this is it's actually a junction of the two schools, and we have this master. We also have now a bachelor in AI, data and management sciences. So really kind of putting the schools together to really have the core of the business and data and trying to develop. And so it's not a program where you're going to only do some kind of case studies with companies. You're going to do a lot of them, but you're also going to have access to a very strong faculty here. Top researchers that are really famous in the world and come from the top universities. So that's really something which is important as well to emphasize. Now, this being said, you will probably have seen the brochure, and well, that the students are quite diverse. This is the current M2, so current one-year program, the student that in the second year of the master. So we have 23 nationalities. So you see, we have people having studied and lived and of nationality from North America, South America, a lot of Europe. Unfortunately, this year, not that many from Africa, which it varied from one year to the other. A strong base of people coming from East Asia, and also from the Near East and Turkey and Lebanon in particular this year. We will kind of soon, we know, because the 10 years anniversary of the master is going to come soon, so I will prepare the actual same map with like all our alumni, which probably going to see where they live, and they're coming from a lot all over the place. This year we only have 40% women and 60% men. The last few years have been more 50-50, so of 48-52 in reality for a few years. So this is something this year we regret that we don't have a full parity, but be aware that we have the specific scholarships for women data sciences with partner companies, Dataiku and 3M, and we are kind of developing further. So if you are a woman and if you're interested, do apply, and we really want to reach parity. So something which is very important. And it's not, we don't discriminate in the application. So we just read as experts that we're very happy that we've had that balance, and we think it's something which is important. A new kind of few new feature this year, which I think that important to know if you've talked to alumni from the past and if you talk to student ambassadors. So essentially, we have a new campus which is specific to the DSBA. Right now, we're using a lot. It's very central in Paris, and it's very important because you may, if you know Paris a bit, you may know that the two school main campuses from ESSEC and Centrale Supélec are far apart. Centrale Supélec in south of Paris, and because it's part of University of Paris-Saclay, which is one of the top universities in sciences in the world nowadays. I think it's number 15 in the recent Shanghai ranking. Knowing that it's a new university, it's because it's kind of combination of existing schools. That's important. And ESSEC is on the western part of Paris. So we have a new campus in downtown Paris, very central, so that you really enjoy the life of Paris and you don't have too much commuting. In ranking, we've regained our position now as number 1 in Europe in QS for the 2024 ranking. And we're now third in worldwide after the UCLA and the MIT. We have a dual degree with the Master in Business Analytics at Columbia, and for students who enter in the first year can do the second year at Columbia, and people at Columbia can do the second year here at the second Centrale Supélec. We're creating new courses, and we're actually revamping the program a bit, so we're going to create a lot more new courses next year in allowing you to have a bit more focus if you're interested, for instance, in finance or in health or different topics. So we will reinforce this. But we've already, like last year, started a new course, and this is something we do also for the second year of the program with McKinsey Quantum Black, and it's actually quite interesting because it creates a good balance with respect to the other very academically driven courses. And we also like a big focus this year is also boosting preparation and corporate fairs and like reinforcing our strong alumni network. So really, because now we're having almost 10 years of existence, we have hundreds of alumni everywhere because we have 120 students coming out of the master every year. So it's a lot of students and former students everywhere in the world. So it's actually quite fun. And it's actually, I mean, even for me, whenever I go in the world, it's actually quite funny that I bump into the streets. It happened to me in Hungary a couple of years ago. Last night, actually, as we're speaking, I bumped into in Switzerland. I bumped into a student in the train. So that's actually something we realize it's quite important for us. Right. So in key features from the students' perspective, so we realize that students have we have a mix of students with and without prior job experience. So that's something we value a lot. I mean, this mix is interesting. As I said, we don't have full parity between women and men, but it's something important. We have also a lot of diversity in the background. And then, of course, if you have more economics and management background, more like a management background, something which is not too technical in terms of coding and statistics, then you may want to enter in the 2-year program. And if you're really strong with coding and you have also prior experience in the field, you may want to join in the first year. The average starting wage at the purchasing power parity right now has been $90,000 US. It's very, it's complicated to compare because, of course, tax regimes are different from one country to the other, but that's what our alumni have been telling us. And our students are working a bit around the world. And they've been working either for large corporations, so industrial, kind of industrial companies, the finance and banking, pure players, and Amazon, or all of this. Or there are a lot of startups they've been joining recently. And I recommend that you have a look at their LinkedIn pages. So either for the joint program, ESSEC and Centrale Supélec, or either the one school or the other, our students may use the different way to express their background because it's LinkedIn does not allow for joint program between schools. So we have to make do with that. Right. So a quick overview. So if you enter in the 2-year program, so you enter the Master 1 for the first year of the program, and then essentially you have 2 semesters. The first semester in the Central Paris campus near Montparnasse Station, for those who know. So you're really going to have the fundamental of math, stats, IS, information systems, and information technology and coding, and also introduction to some economics management, so a bit of finance and game, business games and everything. So it's really like the core of it's very technical in the first semester. It's really like getting you up to gear with all the math, stats, and IT and coding. And then the second semester, this year it will be at ESSEC main campus in Cergy. It may actually differ next year, and we may go back to central Paris once the campus there is fully running. So we need a bit of practice for this year. So you have the fundamental management, so essentially the core courses that we offer the master in management at ESSEC. And you're reinforced in everything with econometrics, statistics, and coding. And you can use some electives like introduction to machine learning or some kind of game theory, or we have a course which is data scientist 101, which is like with companies trying to kind of get you the gist of what the job is about. And of course, hackathons and masterclasses. You can do a summer internship if you wish. It's not compulsory, but lots of students do that, and it's actually very valuable to them. And then if you have done the master 1, then you will enter the master 2 in the second year, or otherwise you directly join us for the 1-year program, you directly go to master 2. If you're a newcomer, so entering directly, then you have in seminars and refreshers, so like the induction period, late August and until late September. So this year we'll be in ESSEC in Cergy because it was refocused here. And it's like refreshers on mathematics, statistics, Python, and then financial accounting, cost analysis, and other things. Negotiation and all these courses, which are seminars, and this kind of preparing you like to kind of this team building, that everything together, and then you actually enter the main program from the beginning of October, and you'll be joined with the former M1 students, so that the whole cohort joins in early October, and that will be in central Paris, so again near Montparnasse station. And then you have the core courses and masterclasses, and I'm going to talk about that in a minute. And then you're going to have data sciences electives and business analytics electives to choose from starting in January. And right now we still have like a staggered version, but until when the main Paris campus is fully operational, like and we've had this kind of period of training, we will kind of mesh a bit more the courses, so it'd be like a continuum rather than a sequential, because this would be very useful for everyone. So basically, then you have this elective, and you can choose any elective you want. There's no upfront you make your choices among the list. And if you want to join the major in AI and digital strategy, that would be in Singapore. So if you want to do that, there's no selection for that. You just have to decide depending on what you want to do. Or we have also an exchange program with a master in fintech at Hong Kong University of Science and Technology, or the master in IS, Information Systems Management. In parallel to this, you have, kind of a key of the program is that you're going to have a lot of group work. So working on projects, that's very important to us. It's very, and the projects are going to be on groups that are very diverse. So trying to, take advantage of all the kind of skill that you've developed before. That's very important. And in parallel, starting in January, so that's going to be January 24, for the current students, and then for you it'd be the year after. You can have what we call a corporate research project, which means that it's a bit like a capstone, but really involved in terms of you have a research work, is that you're going to be working with the groups of 5 students for 6 months, 1 day a week with a company, supervised by the people from the company and supervised by people from ESSEC and Central Supélec, and really kind of being there, developing value for the company, having a really first-hand data science project, which is something which is very important, because it's not just the theoretical courses you're going to do, but you're going to really bring all your expertise to a company and try to really understand what it is to be working for a company as a data scientist. And that's we have realized, we have introduced that 4 years ago, and then we know that it's super valuable, because it also gives you a first-hand experience, so that it helps a lot on the job market afterwards. And then in the summer, between July and December, we actually ask for professional experience. So it can be a job, it can be an internship, you decide. But essentially, you can do as you prefer. But we want you to have an experience applying what you've learned throughout the year or the 2 years before we actually graduate you to the jury, which be for this cohort 2025. If you depending on whether you enter next year M1 or M2, it could be 26 or 27, right? So that's kind of the overview. Very quickly, this kind of the M2 courses. So it's on the brochure, so nothing very, nothing key here. We have 7 core courses, which is the left column here. And you see all the courses are quite technical. So this program is not you're not doing a PhD here, but you are becoming somebody who's very knowledgeable about analytics and data science, and something which is important. You will have a very technical background, but at the same time you are able to bring value, understand the concept of a company, and really interact with anyone with the company who is not a data scientist. And that's what we want to do. So you have courses that are more technical, and courses that are more like computer science, courses that are more business oriented, and this is kind of what we have here. And we have introduced it last couple of years, foundation deep learning, because it's something that you're going to learn a lot. And you know that generative AI is here, and you've all used ChatGPT, maybe Midjourney, Stable Diffusion, and this is important. So you need now to understand the basics of AI. And this is really something we provide. So all the underpinnings of artificial intelligence are here, and we're going to reinforce a bit this few courses next year on that. So stay tuned for more information in the next few months. And then after that, you can choose essentially all these elective courses you see here are all available. And depending on your background, depending on what you want to do, you're going to be able to choose. We want you to really kind of feel at ease. And then you see that lots of courses are more like if you want to go into consulting, if you want to do work in a startup, if you want to build your own business, if you're interested in finance, we're going to reinforce. And if you want to work in health, on biotech, or lots of different fields, these are kind of courses in the M2. So that's kind of the second year, the second year of the program. And if you want to go to Singapore, then you'll have something courses which are more geared towards digital innovation there, and also quite technical, but for some of them, sequential prediction optimization investment. So it's more like online optimization and prediction, right? Okay, so that's kind of with a corporate project in parallel, and a hackathon and a study trip, which will be somewhere depending on what the cohort the students decide. Right, I know I don't have much time. I'm just giving you like a potted overview. So we're going to have integration weekend, inter-cohort parties, language courses, which are important. If you want to live in France afterwards, no compulsory. I mean, then it's not purely compulsory to speak French in France, if you in Paris in particular. But if you want to work in consulting, that would be important, because you can interact with clients that could be anywhere in France, and some of them are not as professional as you would be in English. So it's important also to have that. You have lots of additional masterclasses. A masterclass is something that it doesn't make it into a full-fledged course, but we think is essential. Field trip, hackathon, career center, campus fairs, and company presentation throughout the year. If you want to go into entrepreneurship, we have a specifically dedicated module. If you want to do a PhD right after, we develop a research track next year, so that you can do embark on a PhD right after the master. And that's about it. Kind of jobs here, these are some of the companies that people have been working with are doing the internship this summer. And you see these are the countries where they've been. So you realize that is kind of quite important here in terms of quite varied in terms of locations. A lot of people have been doing the internships in France, and these are the wages the pay that people have been getting for the internship. So France internships are not necessarily very well paid. That's kind of the part of the internship, but if you actually go for the proper job, you see that you end up with something in the right tail here. Sorry, this is it, and I'm getting to the end. I don't know, I have a bit of time. I don't know if sorry, whether you have access to the chat if you want, but otherwise, if you have any questions, you can always ask the student ambassadors directly, so you have access to them, and don't hesitate. There's lots of resources for you provided, so that if you want more information about the program, please do contact. Okay, so you can register and get a lot of more information about it. And I'm available here if the chat is open. I see that there's a Q&A section here in the chat, so I'm available here if you have any questions. So it's next to the chat in the command bar, but I think we don't have much time because I'm already a bit past the schedule. In that case, I look forward to reading your applications and meeting you in the future, hopefully.